There's one clip for the skin, and it's our first system that we're going to start to look at. So up until now, we've talked about the various concepts that are associated with the systems in our body. And now we'll take those concepts of cellular structure, organization, cellular metabolism, uh, the various functions of tissues, and now we'll look at the first system. So in all systems, we're going to look at what is the main organ and what are the accessory organs. So the skin is the largest organ in the body. You know, it covers us all over, and the accessory organs that are associated with it are the various glands, sweat and oil glands, your hair, and your nails. Overall, the general function of it is protection. So I once read an anatomy book, and Dr. Mariab described it as being, if you could imagine an advertisement for your skin, it would be stretchable, resistant to tear, repairs itself easily, waterproof, and lasts a lifetime. I think that kind of covers it in a nutshell, and I love the way that she described that. So there's layers. Let's go to a picture of the skin. Okay, so there's layers of the skin. All right, and we'll look at the first layer. The epidermis. Epi means above. Dermis is the middle layer here, and then we have the subcutaneous layer here. So the epidermis is avascular. So when we talk about avascular, remember we're talking about not having any blood supply associated with it. It is primarily epithelial cells. There's a couple of layers in it that will your skin, the epidermis is multi-layered, many layers of epithelial cells. The ones at the bottom are the youngest, and the ones at the top are the oldest. And so we're just going to look at what are the two. The bottom layer, the deepest layer, is called stratum basal. You can see it here. Where the topest layer, the top layer, the most exterior, is the stratum corneum. Stratum refers to layers. The cells at the bottom here, right down here, have the best blood supply. And as the cells divide and push upward, remember when we talked about various types of epithelial cells? So as the cells move upward, they get further away from their blood supply, they're less nourished, and eventually then they will begin to die off. The youngest cells are the most mitotic. Now, when you get out of the shower, again, remember I probably mentioned that if you rub your skin with a towel, by doing that, you're shedding off the cells that are now dead cells, really. The outer, as I said, the outermost layer is the stratum corneum, and it's easily rubbed away. The dermis is below, so it's the middle layer, it's the sandwich layer, and this is primarily fibrous connective tissue. And the fibrous connective tissue creates the strength and elasticity of our skin. It's quite vascular. As you can see from this picture, there's lots of blood supply. Comes out of the subcutaneous and branches up into the dermal layer. So that brings the oxygen, and that brings that characteristic of the basement membrane. And remember, the basement membrane connects to connective tissue, and this is connective tissue. Our sensory receptors are here. You can see some of them here. All right, here, okay, and here. There's different types. And our accessory organs, so some of the hair follicles and the glands that are associated with the hair follicles. The subcutaneous layer, okay, is down here, okay, and that's a layer below the dermis. So we have epidermis, dermis, and subcutaneous. Cutaneous refers to skin, okay, and it's primarily loose connective tissue and adipose tissue. Works as an insulator to most of us. I mean, as we get older, there's less subcutaneous fat there, but also brings the main blood supply to the skin. So just before we move on, there's a picture here. Remember we talked about the sensory organs that are sensory structures that are associated with the skin. Here's a couple of examples. Okay, there's some sensory nerves there. This is one about touch, and this is one about pressure. Okay, and you can see them housed throughout that structure there. Keratin is a protein that we make in the epidermis, and it's in as the cells are dividing at the bottom of the epidermis and they're being pushed upward, this protein keratin is made. And the purpose of this protein is it creates a hardening process, or what we call keratinization. So it creates the toughness that your skin needs to have. Now, the other thing, people confuse these two cells with each other. They confuse keratin and melanin. Melanocytes are cells within the epidermis. I'm just going to go to a picture here. They're within the epidermis, so you can see there's a melanocyte here. And this is sort of the extension of the cytoplasm of that cell. And what they do is they produce the pigment melanin, and that's what gives our skin color. But the reason for it is it tries to surround the DNA of the cell to protect it. So see, it's protecting the nucleus. So melanocytes are these pigments that are found within the cells, and it tries to shield the cells, the skin cells, from the UV light, and protects us when we tan and things like that, which we shouldn't be doing. The location of sensory receptors in skin. So back to the picture that we looked at earlier. I'm just going to go back to hold on. Okay. We said that there's multiple receptors within our skin layer. Now this looks like it's really thick, but you know it isn't very thick. And there are sensory nerve endings in the epithelial layer that are two main functions, touch and pressure. So the Meissner corpuscles are within the connective layer. So that's these ones here. They look like this. Okay, and they're showing you them here, up here. And those are primarily, they're very abundant in the hairless areas like your lips, your palms, your soles, nipples. And they're associated with touch, light touch especially. And then the Pacinian corpuscles are associated with deeper pressure. So you can see that they're deeper down here. So if I was pushing down here, initially I'd be sensing the regular receptor, but as I push down, there's worry of tissue damage. Say you've got this part of your whatever it is caught somewhere, and that would cause tissue damage. And so when it starts to cause pain, then that's obviously a homeostatic mechanism for us. I'm just going to go back to where we were. So the other thing that's associated, I'm going to go to the next picture, is sebaceous glands. So what we're looking at here is a sebaceous gland, and you can see that the sebaceous gland here is associated with a hair follicle. And it creates something called sebum, which is an oily kind of fatty material with debris that is secreted through the hair follicle onto the surface, and functions really to keep our skin and hair quite pliable and waterproof. Of course, we're always trying to wash it away by washing our hair more probably than we should. And we'll just stay with that picture because we also have sweat glands. And there's an example right here of one of them, right there. And sweat glands, there's multiple, many millions of them in your body. Primarily, there's two types, eccrine and apocrine. This is an eccrine one we're looking at here, which is, you know, the kind we find on our forehead, neck, back, responding to temperature, increased exercise, and they function to cool us. As opposed to apocrine, which are more associated with emotional stress. And so we find these in our axilla and genital areas, and they're associated with hair follicles, and they don't really begin to function until puberty. under the influence of our hormones. How skin is pigmented. Now, there's lots of discussion in your text about this, but we just want to highlight two main sources. Carotene, which is a yellow-orange pigment, okay, that can accumulate in epidermal cells, and it gets converted to vitamin A. So that helps us keep our epithelia cells, tissues, help happy and healthy, as well as our photoreceptors. So we need this vitamin A for that. And if you've ever seen a little baby who loves carrots, and they kind of turn orange if they get too much of them. Melanin, I guess we would as well if we ate a lot of them. Melanin is a black-brown pigment, and it's found in light-skinned persons in the epithelial, and it rubs away. In darker-skinned people, they have the same, but the granules are larger. And remember that the purpose of that is to protect the DNA inside the cell. And of course, this is tanning. So sunlight increases the production of melanin because it knows that the tanning rays might damage the DNA. And of course, a melanoma is the very most serious type of skin cancer. Okay, to finish up this, we're just going to look at generalized functions of the skin. Okay, protection, of course, as we said, it's our integument or our covering, and it's waterproof. So, you know, if you think of someone who's had a bad burn, they've lost their skin, the increased fluid loss is very serious. It can have infection because we don't have that external covering. Anytime there's a puncture in the skin, there's going to be a chance for infection. So it's a barrier. It makes us waterproof. Temperature, this is a homeostatic mechanism, and we talked about it in the first unit about how we perspire, okay, to cool ourselves. So skin has a huge role in that. Vitamin D synthesis. There are cholesterol molecules in the skin that get converted to vitamin D by sunlight, and this is the theory of getting some sunlight every day. The importance of vitamin D, of course, is that if we don't have vitamin D, we can't absorb calcium. That's why we fortify our milk with vitamin D. Okay, so vitamin D plays an important role, and often people who don't get enough sunshine can be vitamin D deficient, and therefore you can see it how it'll affect your calcium metabolism. And then lastly, your sensory receptors. Your skin, we reviewed some types of sensory receptors that we have embedded in our skin, and our skin is our largest sense organ. It is a very intimate sense that we have with our touch, and so again, it's protective. As I said, the more you press on an organ or on your skin, sorry, then the greater the pressure, then we would see different types of pain instead of just touch that we like. So that's the end of the skin, and we will just a short overview. Again, your textbook has quite a little bit more detail, but this is what we want you to understand at this point.